Morning, everybody. I wanted to talk to you a little bit about the weight and gravity worksheet. I posted that a little while ago on Google Classroom. Just want to give you a couple of, looks like one example problem up here. So let's go ahead and go through this. So we're going to use this particular formula, F subscript G equals M times G. You know, it's a subscript. You're going to use this formula to calculate the force of gravity that is exerted on an object. So again, the formula F sub G equals M times G. So you have the force of gravity, which is measured in newtons. All right, your answer is going to be in newtons. It's going to be the mass in kilograms times the acceleration due to Earth's gravity. All right, mass is always going to be in kilograms. And then, so all you're going to do is you're going to take the mass of the object, multiply it by 9.8. Now, the catch is, what we do here sometimes is we talk about calculating the force of gravity that is exerted on an object. Well, a lot of times that object is measured in pounds because, well, here in the United States, we don't like to use metric units all that often. We have pounds and feet and inches and miles and so on and so forth. So what we have to do, you cannot just take, in this case, 3,100 and multiply it by 9.8. That's not the way to do this. What you want to do is make sure that you convert the pounds to kilograms. All you do is divide by 2.2, because for every 1 kilogram, that's 2.2 pounds. All right? And that conversion will be provided for you. You don't have to memorize it, but just remember to use that information. So we have 3,100 pounds. We're going to multiply that by 1 kilogram over 2.2 pounds. So in essence, we're taking 3,100, dividing it by 2.2, and we're getting 1,409.09 kilograms. Now, we have our mass of 1409.09. We're going to go ahead and multiply that by gravity to get the force of gravity that's exerted on, in this case, something that's 3,100 pounds. It's a car, all right, maybe a Honda Accord, for example. So the force of gravity exerted on the car is 13,809.08 newtons. Now, something that weighs far less than that, such as a textbook, for example, or a box of textbooks might weigh, let's say, 35 or 40 pounds. Then you figure out how many kilograms that is, and then multiply that number by 9.8. But the thing is, you cannot take pounds and multiply it by meters per second squared, because this is not metric system, this is. And you can't mix the two. All right? So you have to compare apples to apples. So anytime you see a measurement in pounds, and we're talking about weight and gravity, you want to make sure that you convert it to kilograms and then multiply it by 9.8. There won't be any cases where I ask you, like, I give you the force of gravity and ask you to solve for mass. All right? We're not going to do anything like that. We're just going to multiply mass times gravity. And I'm certainly not going to have you solve for a constant of 9.8 meters per second squared. All right. Now remember, this G here is acceleration due to the pull of gravity here on planet Earth. All right, gravity pulls. Now, I also want to show you a type of problem that I really haven't had a chance to talk about yet, and that is a tension problem. The way these tension problems work, it's relatively simple. First of all, the scenario is you have a block hanging from a ceiling, all right, and the ropes here are massless. We're not going to account for the mass of the ropes. And to keep it somewhat simple, the mass of the two blocks is the same thing. It's identical. All right, so in this case, it's 11.7. Now, so I've got the bottom rope labeled here. We're going to use this formula. And again, it's just mass times gravity. So 11.7 times 9.8 is 114.6 newtons. Now, this happens to represent the tension on the bottom rope, because the bottom rope only has one block attached to it. So 11.7 times 9.8. The top rope has two blocks attached to it. So once we get the tension on the bottom rope, we double the number to get the tension on the top rope. Another way to look at it, you could add up the two masses here, get 23.4 multiplied by 9.8. the 229.32, so that's the tension on the top rope, then, of course, you take half of this number to get the tension on the bottom rope. Right? The bottom rope, either way you approach it, the bottom rope only has one block attached to it. All right? So it's only going to be basically half the tension. The top rope rather, has 2 blocks attached to it. All right? So these tension problems, they're all basically the same thing. The only thing that changes from one to another is the number that I use that's used here. And again, the mass of both blocks is going to be the same. We're not going to get into what if the mass of this block is greater than the mass of this one or vice versa. We're going to just cut that out and keep it somewhat, like I said, somewhat simple here. So basically what you're doing here is you're finding out the amount of tension that is being exerted on each block. Okay? Now, all right, there's also a couple other problems here that may seem a little bit challenging to you, but don't let that deter you or anything like that. Think your way through it, and remember, all you're really doing here is applying this formula for pretty much each and every problem. All right, you're applying this formula. You might have to do a step or two ahead of that before you apply this, but it's the same idea here. But for the tension problem, it's pretty straightforward. All right, mass times gravity. If you just do that, my first approach here, tension on the bottom rope, then double the number to get tension on the top rope, or you can come in from the other side, add up the mass of the 2 blocks first, multiply by gravity. Here's the tension on the top rope. Cut this number in half, and you get the tension on the bottom rope. It won't be. Notice there's a slight discrepancy in the numbers, but that's just due to rounding, and that's perfectly acceptable. So use this information to help you complete the weight and gravity worksheet. And at any point, if you have questions, let me know. I'm more than happy to assist you.